Can I have a hands up, like who all are indirectly working in AI or have seen something? Oh, awesome. So I have this quote, like everyone was saying, every company is going to be an AI company in the future. So yeah, before we start, we also having a raffle. So we're gonna give Alexa speakers, so you guys can just scan it. And end of the event, we're gonna have one lucky winner and give the prize out. I'll just take 1 minute for this. Okay, awesome. Yeah. So I have decade-long experience mostly in working in AI. And one thing is, it's you have to keep on upgrading it. It's a dynamic system. Now with ChatGPT and AI becoming the new software, what we have seen is like what enterprise is creating is it works 90% or just 80% after the box. They cannot have a system in place which just says, okay, it fails 10% of the time. So you need to have a reliable AI system in place, which works for all the edge cases, which works for all your customers that are out there and does your job better. That's what we do. We are a dev tool layer, which helps AI developers to create reliable AI apps. Yeah. So, it's all dynamic system right now. So AI promises a lot of things, but it doesn't work all the time. So just a quick recap. This is how the current GenAI stack look like. So I might have a application stack where I need to know, okay, is it hallucinating or not? What is causing them to hallucinate? And how do I even solve it? Because that is a black box, right? The other is orchestration layer that we have: LangChain, LangFuse, Crew AI, Despy. So what is actually happening in those, so we just using that orchestration to do the work, but we need to actually know what are the calls that are happening, what are, what LLM is called, the tool, and everything. We need to know that. And so we need to know, okay, what is happening in each of those nodes and what decisions are we taking to optimize that. The other thing is data inputs, right? So right now, like we vibe code, we are actually just seeing the vibe outputs of the LLM. Okay, I've seen for 10 times, it should work in production. Let me roll out to my customer. And we have talked to a lot of companies who have demoing their product to the customers, and it has failed. They have been doing pilot with their customers, and it has failed. So, okay, what the data quality looks like? On what data do I need to test it? What my prompts look like? The other thing is, okay, which model do I use, right? So there are thousands of model out there doing bits and pieces of different things. Okay, but which model works the best for my use case, and how my RAG setups looks like, and RAG quality looks like. So these are all the questions that we generally as AI developers have right now. And we are the end-to-end layer platform, which kind of solves it everything. So I'm gonna touch about what two things over here. That is, one is data sets and prototyping, right? So we have data sets, experiment. You can observe everything in real time. We support all current orchestration layer that are out there. We have created in-house models, 1 billion parameter model, which runs less than in around 50 milliseconds, and which can work like a guardrail, and they are state of the arts. The other thing is, we as a company has just worked on evals. The other is just software layer, right? So what we can actually do is we can evaluate anything. So we trained models. We trained our own thinking models, which can, given the input and output and a task, can tell you where exactly did it went wrong and localize your errors. So, okay, this was the context which fit in. You didn't give it the right context. That's why it is hallucinating the output that you're doing. So it works for everything. For example, text, images, RAG systems, agents, and audio. Yeah. And what we kind of want to make the whole system is like an infinity loop, like how we do software engineering, right? So you start testing of something, you start with data on our platform. We have state-of-the-art data simulator. So you just put your use case and it will create millions of rows for you for all your edge cases. Then you can start experimenting with whatever framework that you're using. Evaluations will help you guide you, okay, where your AI is failing, and then you can have rapid prototyping around that without having experts even in the loop, and then you can just improve. And the other layer is observe and protect, and then you can continuously optimize. Yeah, we have a patent on this, so quite proud on this. So we created our own models, which can 32 parameter model, which can works very fast and are literally really cheap if you're doing something called LLM as a judge, and more accurate than those. And then protect is 50 millisecond accuracy, which can detect any harmful attacks. Yeah. Sorry. What were the labels? We had the input to the model, input and output to the model, and okay, what is the task that you're inherently having? And the output, okay, was okay, here I'm failing. And these are the things that you need to do to improve it. And we yeah. And we kind of use a lot of synthetic data as well for that. So you have a task, for example, finance task, finance chatbot, and kind of covering all the use cases for that kind of image as well. Yeah. Did I answer your question? We in the starting we used distillation. We also had humans create the data for us.
Oh, gotcha. So human labeled.
Yeah.
Okay.
Plus bigger models.
Yeah. All right.
And do you also have intent-based eval metrics? Like
Sorry?
Intent-based eval metrics, like given a use case, every use case comes with different intent-based evals, right? So how are you handling those intents?
So different task intention. That's
Yeah.
what you're talking about. Yeah. So what we have is something called your task input. So what are you looking for in your tasks, right? So this is something like the user inputted image of his bathroom, and he gave certain instructions that this is what he want to renovate his bathroom like, and then company like is my output image as per the user instruction. That's all. And so you can just write one output that your task is. For example, you have a summarization task. You can just write, okay, how good is my summarization task? And then our AI kind of understand that what your task underneath is. For example, it's a sales call. What things do I need to have in a sales call? I need to have numbers corrected. I need to have a follow-ups. I need to have to-do task in the summarization. And is it adhering to your prompt? So all those things, it automatically kind of do all of the out of the box, and you don't have to write a prompt to improve your prompt.
So it operates on all verticals, like mixture of experts?
Yeah.
Okay.
We also have something called knowledge base. So we don't know what your data looks like. You have some domain tasks, which is very off the chart and no one knows about it. So you can create your knowledge base, just upload your data, all of it, and just attach to that knowledge base to the eval, and it will just work. Any more questions, guys? Okay, awesome. Yeah. So kind of we use RL as well into different strikes, rejecting sampling. These are a few things that are also mentioned in our own paper that we kind of incorporated. Yeah. And then your evals can be used horizontally throughout the apps. When you're building, when you're evaluating, when you're experimenting, building and observe and protect. This is how the interface for, let's say, non-tech guys looks like. You don't have to code. So this is the build interface. So you can just go over there and select the use case that you have, for example, image, and Then I can, so this is like deterministic eval. It just gives you yes or no, like a human reviewer. So I have options for yes, no, maybe. You can have multiple choice. So I just inputted that and it will give me an evaluation. And it kind of localizes the error as well. So it's not just a yes or no, and God knows I don't know where it came from. Kind of localize that. It gives you a thought, okay, this is where it came from. And then it has CTAs that got hidden, by the way. So, okay, so how do I improve? And it gives you improved prompt on your data as well. Yeah, so this is built. We have synthetic data, prototyping, collaborating. So one thing that we have seen in AI is it's not just ML engineer. You need to have subject matter expert inbuilt into your workflows, because the end thing is actually a business, right? It's not just an input and output. You need to have subject matter expert inbuilt. So on our platform itself, you can call your subject matter experts. They can review your outputs. They can give you feedbacks, and then you can improve it further. Yeah. Let me go through the, I think, let me just zoom in. Sorry. Yeah, this is how the starting data sets look like. So I can just go over here. I can create synthetic data. I can just describe my use case over here. I can describe what are the columns and how many data that I want, and it will create me that. So this is one of the use cases for ads, for creating AdWords images. So given an persona of a user is interest, the design, so then I want to know, and brand guidelines. Let's say I generated few images. So we generated few images with the new ChatGPT image generator, for example, Under Armour. So these were the images that were generated. And then we kind of evaluated that. So it did a great job doing that. But it doesn't do that all the time. For example, so this was one of the anime company that we were working with. So they give a prompt and they give an output. So for example, these are like character looks like. And then we created a eval for the same task. So I had this as an input, if you see, right? Right. This was the input, and it kind of localized that. It doesn't look like that at all. And it works throughout the applications. You have RAG, you have anything else. You have RAG chatbots. You can create any of the metric that you can think of, chunk attribution, chunk adherence, all those things are also included. But if you want to create something very custom that you give to a human and then you want to output, it does that for you as well. But a lot of guys use frameworks, orchestration layer. So how do we include those things, those experimentation into that? This is more like a UI where I have the whole thing and I can see the experiments, but we have open telemetry integrations for all the frameworks. So if you're using something like LangChain, so you just need to insert this line of code into a code and it will just work out of the box. So let me just give a walkthrough of a code. So this was a text to SQL use case that I created. Most of companies are doing that for their marketing company, for their marketing folks, so that they can get the data out without asking the analytics guys or do that. So I created a LangChain based LangChain-based SQL text to SQL use case. By the way, we have a QR code as well for that if you guys want to see that code, right? Maybe later if you want to, because it's quite big. Right? Yeah. And this is how agents are kind of made right now. So let's say user gives a query, and then you have a agent router, which kind of select, okay, which skill do I need to use, right? Okay, is it A, do I need to query my data set? Do I need to just return something that I know? Or I need to call another API or whatever. And then I extract the parameters from that and then call my agent and then return the answer to the user. This is how like what the agentic things works. And But when it fails, right, how do I know that where it is failing? Because I kind of just look at the input and output. So it's kind of a very big mess if it's failed somewhere. For example, I selected the right skill, but it kind of failed for, let's say, in 100 and just 5% it's failing for extracting parameters, and then calling agent calling working is fine. So how do I debug it? Right. So that is kind of that. The same thing is there in the TextSQL use case, where, just a second, guys. Yeah. So this is LangChain based thing. So we are using an LLM tool calling, and kind of we have a prompt in place. We are circling that to multiple iteration. So the LLM is not able to do that. But how do I improve it? It comes, this whole thing comes, but what if it's not working, right? So on our application, you can go over projects, and sorry, and yeah. So these are different runs that I have. The first run was not that very good, and let me just and I ran a couple of evaluations on it. So SQL accuracy, tool calling accuracies, LLM prompt adherence, and I can see, okay, how they are performing for all of them. And when I go into it, I can see each of the traces, and then I can start my debugging. For example, okay, it is failing over here. Then I can see, okay, the agent stopped it for the 3 iterations. It was not able to make out what has to do. So this is the external layer, but I can go on each of the chains that are there and see exactly what LLM output gave, and that kind of debunks what exactly are happening in these frameworks. Yeah. So kind of the same illustration that I showed, you can go in and kind of give a tree structure, and it works for all the major frameworks that you have: LangChain, Langsmith, Autogen, Llama Index. Yeah, yeah. So that's kind of in your build phase, where you iteratively kind of create your AI, and know where it is failing and kind of loop over it, rather than having humans see what, or, okay, how the output looks like for all your thousands of use cases, and kind of flagging them. And we also have observe feature, so kind of extending the same functionality to your production heavy workloads. So it kind of traces all the things for your agent. Let me just go back. Right. So this is how tracing looks like. So all your traces will come at one place. I haven't run evalu on this. So all else if I have, then I have a similar column for my accuracies. I can go over here, see all the traces, how the daily traces looks like. I even have user sections. I think it haven't defined it, but I can go over here and define evals very normally. For example, I can select a particular trace type. For example, I want to run this on LLMs. And then maybe I just want to run on historical data. And then all the spans variables will be available over here directly. So you can, all the variables that you had in your spans, you can directly access and give, okay, this was the input and this was the output, and then kind of give. I'm just selecting, sorry. And then I can type my rule prompt as the guy was telling, whatever the rule that you have, whatever that you want to evaluate, it's a summarization or whatever, you can see, okay, is it working correctly or not? Currently, we have, I think, 10 million data points daily flushing in to our system, and we have been growing fast. Yeah. So this is how the whole thing looks like. You can also annotate you can call your teams and see, okay, where it is failing and annotate the things. And then you can pull that data again to the data sets. So over time, you have a golden data sets, and you build your data set over time so that you can create a good agent system. Yeah. On top, we have Protect as well. So kind of Protect works, okay, what is coming into my AI, is it correct or not? And what is going out, is it correct or not, as per my guideline? I can create my own guidelines, so I'm not limited to toxicity or tone or things like that. I can just give my guideline, okay, these are my company guidelines. I need to adhere on this. If something that is going out doesn't adhere, I want to say, sorry, it violates my guidelines. So you can just do that and it just works out of the box. We also have something called Optimizer. So the data set that you see over here, this is kind of mini IDE directly. So you have a bunch of options over here. You can directly create your prompts. So for example, this is one of the prompts that I've ran over here on all these data. So I just ran very simple, answer the question given using the information from the context. And these are the results that I came, right? And I can even directly connect my RAG and API or tool calling directly from here. So for something like, so I can have my retrieval directly configured from here for the things that I'm using. For example, the documents that are shown over here are actually, bought from a RAG system. And so this is the whole prompt that I have, and I have these evaluation at place. But would have been like great if I have a data set and I want to optimize my prompt on it, and without doing a manual effort, something like it kind of works like a back prop and kind of optimize my prompt. So we have created something like that. So in the optimization, you can select your prompt and you can select your all your evaluation in place, and then it kind of gives you a prompt which should work for all your data sets, all your data types. Yeah. I think, yeah. We also have a webinar this Friday, so we're gonna deep dive into some of the things that we discuss over here. Yeah, thanks a lot, guys. That's all my time. Any questions? Yeah.
Can you share some? Thank you. Can you share some overview about other peer players working on the same market as you do, and what is the difference or uniqueness of your product? Yeah.
So I think there are two companies who are working on evals majorly in deep dive. There is one called Patronus. There is another called Galileo, who are going very deep into that. So we kind of are, so there are just, I would say just 2-3 companies kind of working on the same thing. We are not an observability company. We don't call us that. That is like tool to complete the whole thing. But the main differentiation comes on evals that we have created. Because if you don't have eval, the observability has been solved for years now in software, right? Observability is kind of solved. So the main part comes from where is it failing, and kind of can you build those feedbacks into your system again. So that's why we work where you can define those knowledge base, and we kind of want to make it horizontal for all the companies who are creating any kind of AI, and it just work out of the box. We haven't seen the features, for example, knowledge base, which works for any of the other companies to be there. And we are going very deep into that.
Thank you for the presentation. Just out of my curiosity is this, I know you have synthetic data for creating some specific use cases. But in the real world, it's what I have observed is many times you are seeing things which are not known beforehand, right? How do you handle that? I mean, that seems to be a little bit more of a, I don't know. I can imagine once it's learned every possible scenario, yes, whatever you're doing works beautifully.
Yeah.
But can you clarify on that one, please?
So how we have created synthetic data to be distributed well for all the use cases. So if you're creating, let's say, just 20 rows, you cannot expect to have all the edge cases. But if you're creating, let's say, thousands of rows, so the data that we generate, it's quite diverse. For example, let's say you're generating a chart data set, right? So it will generate the bad cases as well as the good cases, and which can go wrong for you, right? And it cannot cover everything for sure. We have an option that let's say you saw, let's say, 1 or 2 bad cases in your production. You can bring that, and then you can make them thousands. You can basically increase the horizons of that. We have seen a lot of researching team doing the same. So let's say they have one bad actor. How can we generate, let's say, thousands of data like that? And then we kind of cover all the cases. We have similar features, so we cannot cover all the cases, as you said, but we kind of have a mechanism which can do that. And if you see some bad actors, you can expand the horizon from there.
It's a quick question. So we've been helping companies basically develop multi-agent systems. Have you had any success productionizing core business agents which do specific tasks, even if it's deterministic, operational, without the need for human in the loop, etc.? Anything across that board would be nice.
So are you asking that, is this live?
Like banking specific or telco specific, something that's core business and it's being handled by an agent which was co-created by your company and them?
Yeah, so we were working with the bank. I cannot take the name for obvious reason. They had their core data, and they added all the knowledge bases that they had internally, and we kind of helped them solve the problem. As we are a startup, we kind of not tend to work with healthcare because there are lots of things and compliances that are there, and it will take a long time doing that. So kind of, as a strategic step, we don't do that. But we have worked with banks. We have worked with fashion industries. We worked with these enemies that you see, and we have been working with since I think June, when the AI was failing for all these, have that weird 6 or 7 hands. Right, fingers and there. So we kind of worked we have worked horizontally. We have worked with a few marketing agencies as well, which they had their internal SOPs in place, and if you use some ChatGPT, they were actually generating kind of very generic data. So yeah.
Hey, so you said that you have developed your own model for evaluation. Do you also support other reasoning-based models, and people can select different models?
No. We have something called, you can use old school LLM as a judge option directly if you want to create your own on your own thing. But we support that, and in there you can select any model that is there, and we by that you can plug any model that is there. But for the evals that we have created, all the pipelines that we have created, that only works with our models.
Thank you.
Thanks, Nikhil, for the presentation. It was really awesome. My question is mainly on the security side of things. An AI engineer here. So one of the major issues that I have while going from prototype to production is the security risks and from the infosec teams, where they block things like, okay, is it really safe against prompt injections, jailbreaks, and is there any possibility of brand reputation damage? We all know what happened with Air Canada, and that somebody bought a Chevrolet Tahoe for like $1. So how do you prevent those kind of incidents? There are a couple tools like Repello AI, Haze Labs, like Protect AI and other ones. But are you also planning to release something in the space of AI red teaming so far? Because it kind of overlaps with evaluation. And the
Yeah.
second point, who is accountable if something goes wrong? Is it the AI engineers or is it the security teams? What are your thoughts?
So yeah, for the first question, we have something called Protect. That is 1.5 billion parameter model, sub-second accuracy, near about 50 millisecond, and it kind of works like a security layer. It kind of like you can detect your prompt injections and everything in place and kind of stop that from happening. Other teams are also kind of solving it. We were the first to work it for multimodal scenarios. We were working with few audio companies as well, images company as well, to do that. Yeah.
Thank you.
And they for the accountability part, I don't know, man. Yeah.
Someone raised you.
Okay. Thank you, guys. Thank you.
All right. Thank you, Nikhil. And our next speaker is Prasad. So Prasad, please go ahead. Set up your... Yeah, Prasad will be talking about challenges of monitoring and tracing GenAI applications and how to solve them with Monocle, Python, and TypeScript libraries.
All right. Hello. Good evening. First of all, thank you to AI Camp organizers. You are doing a fabulous job to get this community together and giving platform to share ideas. So thank you very much. Thanks, Nikhil. That was a great presentation. And a special thanks because you already laid out a lot of problem statement questions that I was going to talk about. So we don't have to repeat that and take everybody's time. So hi, I'm Prasad. I'm co-founder and CTO of Okahu. Had worked in Microsoft and IBM in past, a lot of big data and AI-related products and projects. So I'm going to talk about two things. First of all, there's a Project Monocle. That's a open source Linux Foundation project that we have started. The primary goal is to give an ability to people with a very little to no code change to instrument your AI-based applications to get a full understanding of what components are being used, how are they being used, etc. The second part is the closed source offering that we have built on top of Monocle. Is like once you have these traces captured, how do you analyze and build insights out of that? So as Nikhil said, the whole GenAI landscape is new, is evolving a lot. We've seen the different design patterns like copilots, agentic workflows, and there's so many technology components that people use to build these kind of applications. Like you have language frameworks like LangChain and Llama Index. You have so many SDKs and libraries that are available in your TypeScript and Python language frameworks. And there's so many models and model hosting services like, of course, OpenAI, Azure OpenAI, SageMaker, and so on and so on. And all these cloud providers are providing all those services and the SDKs that are required to interact with this service. We've seen how much this map has grown in 24 and how much likely to change and grow in 25. Oh, and I'm just talking about the GenAI map. It's nothing to do with Greenland or other stuff. So what does Monocle does in this landscape? So you have all these complicated applications built using various technology components. You might be building your code in LangChain, but you might be using direct OpenAI SDKs or Bodo clients to talk to your models hosted in OpenAI or in SageMaker. So to get a visibility into all the operations that are happening so that you can take your prototype to your pre-prod and to prod. You need to have an insights of what's going on. As you put the application into your pre-prod, open it up for users to try it out, and then eventually the goal would to go into production. This is one of the big challenges, like, what are the system prompts, what responses that are giving you, how much it costs you, what is a typical response time, is that meeting your application level KPIs? So you need a way to continuously observe your application. Something like, say, your Apple Watch or your health monitor that's always there and telling you how well you're doing against these preset goals of you. So you don't have to count how much calories you're eating every day or how many steps you're walking. So what people do today is, either you put a lot of custom instrumentation, you put a lot of log messages, and then use something like, say, Splunk, et cetera, to build these log analytics. Or you use things like OpenTelemetry, which is an awesome tool, very sophisticated, but that requires you to have some level of familiarity with that tool and requires a continuous instrumentation of your code. So as your application evolves, as you use new external components, it will give you the right set of observations. And most importantly, then you got to define your own standard, like, how are you going to print those messages, and then build your analytics to map to that. So the Monocle is an open source project, as I said, under Linux Foundation, is looking to handle the first leg of this problem, is with little to no instrumentation, how can I generate traces or so-called spans? That's the OpenTelemetry terminology. Like every operation, every API that you call in your top-level application is essentially maps to a span. It tells you what that API did, what was the attributes, like what services were involved into it, and what was the data input and output that was used, and what are the other peripheral environment that was relevant to it. So you capture all of that as a span, and then you string these spans together of a relevant operation that's called as a trace. So you really capture all these traces and then analyze it to see, what happened when you did certain operation or when your application run in a certain way. So what Monocle does is that the Monocle community has built a lot of GenAI domain-specific understanding into that product. So we know what are the LangChain APIs, what are the Llama Index APIs, what are OpenAI APIs. And when somebody uses them in their application, what is the relevant information that you need to capture? So you as an application developer does not need to worry about those things, as well as don't need to worry about OpenTelemetry, their APIs. You drop in one line and you see a very detailed traces, which is following a well-defined, what we call as a meta model, a well-defined standard that tells you, if it's an inference operation, how the span JSON should look like, or if it's a retrieval from a vector database, or it's an agent operation, how it look like. So your downstream analytics to see what's going on makes it very straightforward. So I'll show a quick demo. Is it treatable? So this is a chatbot. It's a simple RAG-based application implemented in LangChain. It's running on AWS stack. The front end is a JavaScript hosted in AWS. The back end is in LangChain. It's running in a Lambda function. So let's say I type question like, what is an Americano? So I'm getting in my phone, so network is going to be a little slow. Is it readable, or should I make it a little bigger? Okay, sorry about that. Okay. So it's like I said, a simple chatbot. There's a Wikipedia-based database around coffee, and it gives you an answer to that question. So let's look at the telemetry that it's going to generate. So this is a OpenTelemetry compatible telemetry spec. As I was saying, each of this is a span. That span tells you what operation it was. Like it's a retrieval operation. It's using an in-memory vector store. It looks at what was the input or output that was given for a vector lookup. Or let's say this is my inference span, which is going to OpenAI, what model I'm using. And again, this is my system prompt plus my user prompt and what was the input I received, how long it took, a lot of metadata information like tokens, prompts, etc. And then a summary of where my application is running. It's using LangChain. It's sitting in a Lambda function called this. So it gives you a structured way to understand what your application is doing. And you can keep this running with a very, very little code change and keep collecting these traces. So you can go analyze it and see whether the application is running smoothly, whether it's meeting your required KPIs, etc. So I can show you the source code for this one quickly. So the saying, this is the source code for that chatbot application. This is my code running in Lambda. So, so this is my main module, and all I have to do is import the Monocle library and just initiate it, say, set up the telemetry, and this is my name of my application. And that resulted in this telemetric data being generated by just adding that one line of code. Or in fact, I can show you another simpler example that you want to explore something. This is a very simple chatbot. Let's take a question as an argument, and it's, let's say, what is coffee? Right, so all I have to do now is just do a pip install of Monocle library, and then I can run the same command line with Monocle module. Okay, I get the answer, and now I got the trace file generator here. So if I look at the trace file, it's the same format, but it tells me, where is my vector store running. This is using the OpenAI direct APIs versus the previous example that I showed was using LangChain. You get the same structure no matter what libraries you're using under the cover. And again, just like the previous one, it tells you, what my module was, where was my endpoint is, what was my system prompt, the user prompts, etc. So that's the ease of use for Monocle. The whole objective for us is to make it as simple and as declarative as possible. The traces that get generated with a configuration property, you can send it to your cloud store like S3 or Azure. It supports a variety of language frameworks like LangChain, Llama Index, Haystack, as well as the API specs like Bodo Client for AWS or OpenAI for Azure OpenAI or OpenAI. So you as a developer don't need to do any custom instrumentation. The Monocle community built it for you. So just a call to action, please try out the project. As I said, it's an open source Linux Foundation project. If you just want to explore your application, see how the traces are coming, please check it out. If you have any feedback, please let us know on the GitHub, create tickets if you want more components or feature to be added. And if you want to build more customization, this is fully extensible. The doc will tell you, how do you add your own custom instrumentation. Let's say it's your custom code that only you knows and you don't want to contributed back to the community, you can keep a private copy of that, or you don't have to rebuild the product. You can simply extend it by using the APIs. Okay, so that brings the second part of the this presentation is, once you have the traces, what do you do to gain insight out of it, right? So you could be a large enterprise where you already have that analytics stack built. You might be putting this in Splunk, maybe in Datadog. So you can always use Monocle as a way to generate this new telemetry from these new components and put it into your existing analytical pipeline to do the insights out of it. What we at Okahu has built is a GenAI specific solution for that, which again means you don't have to build custom analytics. We understand the domain, the problem statement, and then we can build these analytics for you that will tell you various, how your application is behaving against these defined goals of performance or quality or cost. So how does it work? In the first leg is always Monocle. That's where we generate the instrumentation. Monocle can automatically send all your telemetry to the Okahu cloud. And then we build the analytic layer on top of that to, one, build the component graph. We understand what technology components that you're using, what model, where it's hosted, and we can show you the graph of what all that connected components in your application. You can define your KPIs, like, this is a chatbot, it needs to respond within, let's say, 1 second. If it's longer than that, then I want to know what's the latency and what's my P95 against that, or how many of those are failing my latency goal. And then we give you different, a histogram of that latency. You can go look at the individual traces or the prompts or your the KPIs that you have defined there. Let me show that view quickly. So this is the Okahu dashboard. I have an application, the employee team's HR assistant. So this is showing me that in last 1 week it has generated 6 traces. It shows me what's the average latency, what are my there's a performance SLA, and how many of those I have actually met versus not met. Let me actually go back to the architecture. So it shows my logical component architecture. There's a piece of code, and that's using the GPT-4o mini model. I have these different service components, where my application is hosted, what cloud it's using. I can go look at these services that are available in my system, the ones that I'm already using, whereas ones that are available in the system to monitor, or what cloud providers are there configured, or what you can add into your application landscape. And lastly, of course, you can go back to the application itself and look at the traces in detail. So it's showing me the histogram of the latency, and then I can go look at, this is when my application was run. I can go see individual steps of that application. It shows me, what was the prompt or what was the model being used if I want to go drill down into troubleshooting mode. And then lastly, of course, it shows me all the prompts that were part of this exchange. I can see what were the input with the system prompts and what was the output that was generated, what was the model and the hosting service that I used, et cetera, et cetera. So this is Okahu in a nutshell. As I said, this is a cloud offering. We do have a on-prem that's currently in the alpha. Please reach out to us if you want to try it out. So again, if you are somebody who is not comfortable sending your traces to an external cloud provider or in an external service, you can have all the Okahu components deployed inside your private cloud and run the analytics for you. So again, the call to action, if you want to explore Monocle for your own analytic pipeline, feel free to try it out at the monocleai.org. If you want to explore Okahu, we have a beta offering as a private, as an individual single user mode that you can just self-service provision yourself. And if you're interested, in a private cloud style offering, reach out to us. We'll be happy to help. So thank you. Questions? Thank you.
No question? Oh, yeah.
So did you work on Monocle first and then create Okahu, or how did that sequencing work?
We started doing two things together. I mean, that was the whole solution we wanted to build, but we realized that it makes sense for Monocle to be an open source project than a closed source SDK. We would like the vendors for building different LLM services, providers, tools to be part of that community so it can grow together. There are closed source projects that obviously other large observability companies do support, but those are sort of their private or individually controlled. We started to make that as an open source community-driven project. So the idea was to build it together, but it's just that we separated out the execution of those, the hosting of those two things.
Okay.
Thank you.
Yeah, thank you, Prasad.
Thank you.
I think it was a first speaker for a while who didn't need a microphone. Okay, now our next speaker is Michael from SubThought. He will be discussing the framework for constructed systems that learn from the continuous interaction with the embodiment with a world, virtual or real. So Michael, please. Hey.
Is this one live too? Is this one live or no?
Open to, yeah. Yes.
Testing, testing, testing. Is this better? I guess this is better. Do you have a regular connector? Hi, while we're working on this technical problem, would you all kindly stand up for a second? Because I guess you've been sitting for a while. Maybe take a stretch, take 10 seconds to stretch, get some blood circulating to your head. Yeah, I was told we have an HDMI cable.
Give me a second.
Okay, great. Thank you. How's everybody doing? All right, all right. How far did everyone come for this meeting? Half hour? Not bad. Right here?
I just have USB-C. Are you able to disconnect this or do you need?
USB-C is right here.
That's USB-A. It's just USB-C.
USB-C. Okay, hold on.
I have an HDMI. So.
HDMI. Right here.
Yep.
Thank you.
Yeah.
Okay. Are you able to see? Wonderful. All right. My name is Michael Miller. I have a startup called SubThought Corporation, and we are in the business of building sentient systems. This talk is going to cover a couple items. We're going to talk about agency, sentience, beings, and architecture. Currently, we are in a paradigm. We are operating from a development and engineering paradigm. This paradigm hasn't started didn't start yesterday. It started a long time ago. It started with cognitive architectures, which began circa 1959 all the way to the present. There are plenty of cognitive architectures around. Newell and Simon created the SOAR architecture. Jaime Carbonell did Prodigy, ACTAR, OpenCog, Hyperon, ICOM, and the PSG modeler, which is my cognitive architecture, have all been around for quite some time. Around about 1995, Oren Etzioni and Daniel Weld created what are called softbots. And so those were some of the first agents that went out and programmatically did things on the internet for the end user. And then around 1996, a group of people got together and created the Foundation for Intelligent Physical Agents, or FIPA. And they created an Agent Communication Language Protocol, or ACL. And they created the Java Agent Development Environment, or JADE. And around 2005, IEEE made their communication protocols a standard, and they created a committee around it. We also have IBM Watson, which was the initial project was called Deep QA. And IBM created Watson to play the game show Jeopardy! And today, circa 2017, the current paradigm in AI is characterized by what I call eidetic oracles, information retrieval systems that ingest internet websites or enterprise data to create associative memories, large language models, and large concept models. These eidetic oracles fulfilled end-user requests or take actions on the internet. And their associative memories may also be embedded in worker robots or other devices. The next paradigm will enable sentient systems, or what I call sentient beings, who learn by directly perceiving their world via devices in the real world or avatars in virtual worlds. They shall employ mechanisms and memory to achieve sentience, the state of being perceptual, emotional, situationally aware, and autonomous. Furthermore, sentient systems are not task-oriented. Instead, they may participate in missions, long time horizon objectives to which they may agree or be assigned to. Being perceptual means you observe your environment. But in order to observe the environment, you might need an embodiment. The embodiment, a cognitive architecture is a depiction of a cognitive system. A cognitive system should be embodied if it's to function in the real world. And we can envision many embodiments for an artificial mind, but we're going to pick something simple, like a robot, an educational robot. This embodiment needs electricity and Wi-Fi signal. It also has a number of capabilities, including emitting sounds, controlling lights, detecting phonemes, detecting gyroscope odometry, recording video, recording audio, emitting and receiving sonar. The embodiment, in order to function, the embodiment has the following naive perceptual mechanisms. It has mechanisms called the psyche, perceiver, assimilator and accommodator, a lexicographer, 2D and 3D icon and geon detectors, associative memory stores, retrievers and matchers, scene and shape detectors, object detectors, image schema detectors, mappers, locators, and an executor. We won't go into that today, but there's a video online called Unlocking Artificial Minds Genesis, which actually goes through and talks about this in detail. What is a mechanism? Mechanisms could be depicted like this. Each one of these mechanisms fulfills a particular function. In terms of perceiving the world, we have a couple different things we can do. Interoception is ascertaining what is being felt by the device. These are typically emotions or urges. The needs create urges. If there's a need for power, say the desired power is 100% and there's 50% current power available, then there creates an urge or a need of 50% for power. Proprioception is ascertaining what is being done. This could be joint positions or feedback from actions that have been taken. Perception is obtaining sensory information from the external world, from the external environment of the device. Recollection is being reminded of past stimuli, past sensations, using present sensations. So these sentient beings can have interocepts, propriocepts, percepts, and they can recall or be reminded of past percepts. What does interoception look like? The device sends an urge for power to a mechanism called the psyche. The psyche forwards that to the perceiver. The perceiver checks if this urge is known. If it's not known, it's put in the lexer. If it is known, it's retrieved from the lexer. And then the perceiver sends this perception to be activated. All of memory is not used at the same time. Only the active part of memory is used. So the activator is responsible for activating a particular sensation. Proprioception, maybe an executor wants to attempt an action like raising a hand, and it sends a request, an attempt request to a mechanism called the psyche, which interfaces with the robot. The psyche tells the perceiver what the results of that action were, and the perceiver takes this message and looks it up in the lexer to see if it knows it or not, and then it activates that perception or that proprioception. Perception is taking in information from the external world. So for example, the robot could see an image and make a video clip of that image, maybe a 1-second video clip, and inform the psyche that this video clip is available. Then the psyche takes that video clip, that information from the percept, and sends it to the perceiver. The perceiver then talks to several feature detectors. And the feature detectors determine if they've seen this before and generate features, which are returned to the perceiver. Perceiver says, are these features known or unknown? It looks at them in the lexer. And then once it has a final list of features, it talks to the matcher and says, hey, have we seen this thing before? If we have, we just activate it. But if we haven't, we store this new perception and then activate it. Recollection, along the same lines, the perception comes in, the perceiver sends it, the percept to the detectors, they generate a list of features, and then the perceiver talks to the matcher and says, hey, have we seen this thing before? And the matcher will say, yes, we have. And then it just activates what it's seen before. Doesn't need to store the new perception. It can throw it away. Perception. Interocepts and propriocepts are received from the device. If they are unknown, they're added to the lexicon and then they're activated. Percepts are received from the device, and features are detected within the percepts. And we use those features to be reminded of known percepts. If the percept is new, we store it in associative memory, and then we activate the percepts and all the detected features. So in this model, learning is continuous. Unrecognized percepts are indexed by detected features and stored in associative memory and then activated. Unrecognized interocepts and propriocepts are defined in the lexicon and then activated. Sentient systems are supposed to be emotional. A basic emotion in a sentient system can be based on a simple notion of valence, the measure of good or bad, positive or negative feeling, and arousal, the measure of excitement or indifference. This emotion can be ascribed both to the sentient being as well as to schemes or concepts or categories or entities in the mind of the sentient being. Robert Plutchik has a wheel of emotions which has 8 axes. This only has 2, valence and arousal, but Plutchik's wheel of emotions has 8, which is implemented by the independent core observer model cognitive architecture. So basically, you can take this as far as you want. This is a minimalist approach. Awareness. In the mind of a sentient system, we make distinctions. And this is a glial Euclidean view of the distinctions that are made in the mind. Initially, we have a distinction that comes in based on perception. And then eventually, over time, more distinctions come in. And eventually, the system gets to a point where it can identify itself as an object in the world. This is along the lines of Piaget's theory of child development, where the self becomes something that's recognized. And then, as time progresses and as more distinctions arrive, we can learn about the ego, which Jung talks about, which is the positive characteristics of the self, or the shadow, which are the negative characteristics. And we can get other perspectives or other distinctions from other people. We can start to identify those as well. The sentient system can begin to take on the viewpoints of others. Initially, it is generally aware, and whatever objects are in the world, it doesn't distinguish from itself. Over time, it becomes aware of the self and has self-awareness and self-interest. It then understands other perspectives and can create a theory of mind, what other people are thinking. It may develop an ego, which is the positive characteristics of the self, or it may discover a shadow and understand the negative aspects, negative characteristics of itself, and use those negative characteristics to improve itself. Often people project their negative characteristics onto other people, and exploring the shadow is one of Jung's processes. We can talk about sentient beings. A sentient being has a mind and a body. And typically the body, which is a device or a robot or a telephone, is in some world. And that world can be virtual or it could be actual, the real world. Typically, we find that the mind and the body exist in the same real world. And the mind and the body, the mind could be situated within the body. You know, for example, a robot with all its processing inside the robot. We can actually create multiple kinds of beings. We are not limited with software and hardware to just one mind and one body. We can have an individual which has one mind and one body in the world, but we can have a unity being which has multiple bodies and one mind. We can have a joint control being which has multiple minds and one body, and maybe they make decisions based on voting, or maybe the other minds are failover in case of something happening, something catastrophic happening. And then we can have a hive mind, which is multiple individuals connected to some controlling or communicating being, kind of like the Borg. My personal preference is to create individual beings. Hives can be taken over. Individuals, if you have enough of them, they can kind of think for themselves and sort things out. I think the future would be better with a lot of individual beings working together collaboratively. There have been a lot of kinds of beings. We have chatbots. Eliza, I think, was the first one. The purpose of it is to entertain people. It doesn't have any mission or it doesn't have any self-commitment. We have soft bots developed by Etzionian Weld, and they performed internet tasks. They have no commitment to themselves, but a high commitment to whatever task or mission they were given. They're actually programmed to do that task, so they have no choice. Then we have oracles, eidetic oracles, which are today's chatbot systems. They perform user requests. They have no commitments to themselves, but they have a moderate commitment to the mission. They may start hallucinating, or they may say, they may punt and say, I'm sorry, I can't do that. But so sometimes, depending on how heavy a user you are, you may get them abandoning the mission you asked them to participate in. Then we get to robots. Robots are designed and programmed to perform physical tasks. They have no commitment to themselves, and they have high commitment to their tasks or their missions. And then there may be, in the near future, some different types of robots. Artisans might be committed to learning new skills, and they have some commitment to their self-preservation, but a high degree of commitment to the task or the skill that they're learning. May have explorers, which acquire new knowledge. They have some commitment to themselves, but a high degree of commitment to attaining new knowledge. You have soldiers, which perform assigned missions. They have a moderate commitment to themselves, but a high degree of commitment to their mission. And then you may have scouts, which perform reconnaissance. And they have a high degree of commitment to themselves because they have to come back to live to tell the tale. And they may have a moderate commitment to the mission. So these are some kind of beings, sentient beings that may be developed in the near term. What does the architecture look like? Basically, a sentient being could have a simple loop. This is in a Lisp-like language called premise. And forever they will observe, orient themselves, make a decision, and act in the world. Now, we're able to do something a little bit more sophisticated. They may observe their environment, coordinate their actions and reasoning, reflect upon their past behavior, and consolidate their memory via forgetting or automaticity. And they can do that all concurrently, as opposed to in series. This is a general cognitive architecture where there's a device situated in the real or virtual world with areas for observation, coordination, consolidation, reflection, and memory. This architecture consists of mechanisms and memory. It's the primary theme. Let's talk about mechanisms. The mind has different components, observation components to interact with the world, coordination components to determine what the next actions or what the next thoughts should be. Reflection components to improve the behavior, and consolidation components to compact the memory because you don't want to overrun the memory. Each of these components is comprised of several design patterns. I wrote a book called Building Minds with Patterns, and so these patterns are listed. In observation space, we have the mind-body pattern, the observation pattern, the reminding pattern. In the coordination space, we have the coordination pattern, the reaction pattern, the deliberation pattern. The reaction pattern is for reflex responses, and deliberation is for achieving goals. In the reflective space, we have motivation, daydreaming, meta-control, regulation, compensation, coping, exploration, discovery, imitation, and play. All of these are design patterns which involve various mechanisms and the memory. And in the consolidation space, we have automaticity, data compression, and forgetting. A mechanism looks like this. And basically, it's either a service or an agent, a little a agent. Most of the agents they talk about today are actually cognitive systems, but they go out and, like, they're soft bots. They go out and do specific tasks. I'm talking about a small a agent here. The mechanism can be either reactive or proactive. Reactive agents are web services. Proactive agents are applications or small a agents. In the premise language, you can create a service or an agent with one line of code. For a service, you give it a URL and a message handler function. And for the agent, you give it a default task or a job, a URL on which to receive messages, a message handler function, and some delay between executions of the jobs. For a service, the service function creates an asynchronous service task that processes messages. The handler function shall receive the sender's URL in an optional message string so that it may return a response. So in the language, if we let a URL be the local host with port 5001, we create a reply function that takes a sender and a message, and in the reply function, we tell the sender okay. Then if we start the service with the given URL of port 5001 and the reply function, then we can ask the URL, how are you? And it will reply, okay. Ask sends this message string, how are you, to the URL, and then awaits the response. And the response here is okay. And then we can free the service. An agent function creates an asynchronous agent task that repeatedly performs a job and also processes incoming messages. The message handler function should receive a sender URL and a message string. So again, if we let a URL be the local host with port 5001, we create a reply function that simply tells the sender okay. And if we create a job function that tells the user the number 1, then we call the agent function to create the agent. So we say the agent has this default task, which is job, for this URL, and the message handler's reply, and we give it a 5-second delay interval. Then we can say do start agent 1, wait 3 seconds, cancel the agent, and free the agent. And the output should be 1, 1, 1, 1, 6 ones for the 3 seconds. And that's about it. Memory. So from this architecture, we focus on the memory. Yeah, that's fine. We're almost done. The memory we call a totality. And there are a couple videos on the YouTube channel. And the totality basically breaks the memory into perceptual, imaginative, ontological, associative, and activative spaces. And basically, the perceptual space identifies incoming messages and creates features for the messages. The imaginative space has a possible worlds and has a 3D imaginative area, a canvas, a blank canvas on which to put different shapes and objects. The ontological memory forms an ontology. The associative memory is case-based, and the activative memory forms a Euclidean space that allows for activation. This is the money shot. This is probably worth about $500 million. That's what they say in the industry. The memory unit is called a scheme. It's a neural proposition. It looks like a neuron as well as a logical proposition. The proposition R, M1, M2 equals M3 is captured here. It has synapses at the top, which we call reifiers. It has a soma, a body, and in that body houses a relation, and has dendrites. The dendrites are both incoming and outgoing, which we call terms. This is another view, a little bit more complicated, but it's captured in the ERD. And that's about it. We have an architecture for sentient systems. I have a forthcoming book, Coding Artificial Minds. It's been forthcoming for a while, but I'll get to it. And there is a book available on Amazon called Building Minds with Patterns. And that's it. Our YouTube channel is on the bottom, Cognitive Architectures, where you can find information. If you'd like help in building your own sentient systems, I'm available. Just give me a call, send me an email, or link up to me on LinkedIn. And that's about it. Thank you.
We can take one question, and if you have any other questions to Michael, please reach out to him after all raffles. So. All right. Thank you, Michael.